So let's look at example number 1 here. It says that Jasmine is climbing a hill which has an angle of elevation of 4 degrees. That means from the horizontal up is going to be 4 degrees. So let's draw a little right angle triangle. Okay, it doesn't have to be super accurate, but as long as it kind of looks like a right angle triangle, we can at least label it, and I can recognize if you have done, put the values in the right spot. So angle of elevation is 4 degrees. That means from the horizontal up, this is 4 degrees. Now she's walked for 3 hours, or after 3 hours of walking, Jasmine has walked 8.4 kilometers. She is walking uphill, meaning that her walking is 8.4 kilometers. Now it's asking for how many meters above her starting point is Jasmine after 3 hours. This is her starting point. This is her ending point, or at least the 3 hours later. We are looking for how high up is she. Okay, how high up is she? This is a right angle. Now, in this question here, we're given the hypotenuse. We're asked to find the opposite side, and we're not too worried about the adjacent side at this point. Okay, again, it's important that we recognize what piece of information we are dealing with. So, to find the opposite side, we're going to be using our sine function. And so sine of our 4 degrees is equal to the opposite, which we don't know, over the hypotenuse, which is 8.4 kilometers, over 1, opposite. So we got 8.4 times sine of 4 divided by 1 is 0.58595 kilometers. Now you're like, well, Mr. Barkman, why did you write out so many numbers? Well, we're not done yet. What does the question ask? It asks for how many meters above her starting point is Jasmine. We found kilometers. So before we do anything, we need to change this into meters by multiplying by 100. And she is 585.95 meters above her starting point. Make sure to watch and read the entire question and to answer it in its entirety. Very important that we do that. All right, number 2, Liam is standing 40 meters away from the water tower and measures the angle of elevation to be 50 degrees to the top. Okay, that should have been mentioned to the top. What is the height of the water tower? Well, let's start off by drawing our water tower. Now, most of you probably know what a water tower looks like. Okay, there's our water tower. What we're going to be doing here is we're going to be making our triangle as such. Now, I realize this might seem a little bit odd because you're not going to look right through there, but we're going to envision that we do. We have an angle of elevation of 50 degrees, and we know that he is 40 meters from the water tower. We're trying to figure out what is the height. Okay, height of the water tower. So, label it adjacent. Sorry, that's theta. This is hypotenuse. This is our opposite side. We have the adjacent, we want to find opposite. So that means that we need to use tan of theta, and we know that that is opposite over hypotenuse. All right, tan of 50 degrees is equal to opposite, which we don't know, over the sorry, not hypotenuse. Nobody corrected me. Oh man, really need to get some people into the class here when I'm videoing. Opposite over adjacent. We know the adjacent is 40 meters. I hope that all of you at home were catching on to that, or while you're watching the video, caught on to that. And so we're going to do then 40 times tan 50 divided by 1. And our opposite is equal to 47.67 meters. So again, it's context, so we give a contextual answer. The water tower is 47.67 meters tall. And that would be our contextual answer. All right, so that is our contextual answer. One more example, and this one is a little bit tricky, but is also a little bit of fun as well if we want to kind of think through in math sense here. We have an octagon right here, and a table is in the shape of an octagon, and we want to determine the perimeter of the table. Yikes. Okay, we're given one dimension, and we want to now try to figure out what is the perimeter of the table. Now, this question is a little bit difficult, but if we do see something that looks like this, and you might, let's think of this as being triangles. Oh, should maybe redo my line there. An octagon can be made into 8 triangles. There, let's do it like that. Okay, 8 different triangles, and inside a triangle, if we cut a triangle in half, that is a right-angled triangle. Okay, it's a right-angled triangle, and that means that our hypotenuse of that triangle is 15 centimeters. Now, we want to find perimeter, so we want to find, if we can find this distance, we can then multiply it by, well, it'd be 16, because there's 16 halves of the triangles, to come up with our total perimeter. The problem is we don't have an angle. And it's hard to just say, well, this looks like this. Yeah, we can't really say that. But this piece right here we can find. There are 16 half triangles in this whole circle, and we know that a full circle is 360 degrees, and so we're going to divide that by 16, and that is 22.5 degrees. So this is 22.5 degrees. Okay, the full circle, or all the way around, is a 360. This is 1/16, so we divide it by 16, and that gives us our angle. Then, all of a sudden, and I'll draw this out a little bit bigger so that we can kind of do some markings on there. Okay, so what we know is this is 15 centimeters. This is 22.5 degrees, and we're trying to find what is that distance right there. Opposite, hypotenuse, theta, adjacent, which we don't need, but we can still at least put in there so we know. All right, we want to find the opposite. We have the hypotenuse, so we're going to use our sine function, opposite over hypotenuse. Sine of 22.5 degrees is equal to the opposite, which we don't know, over the hypotenuse, which is 15 centimeters. Cross multiply and divide. Do it with a calculator. 15 times sine 22.5 divided by 1. This is 5.74 centimeters. That is one little bit. Then we take 5.74 centimeters and we multiply it by 16. I'm just going to multiply this by 16. And we get 91.84 centimeters. All right, I know that's a lot of work, a lot of little intricacies. If you have questions, you can ask in class. The perimeter of the table is 91.84 centimeters. Okay, we find the edge of the triangle and we multiply it by 16. Now your assignment, you're going to be completing the assignment. That's Trig 3, questions 1 through 15, TR.03, numbers 1 to 15. Now again, there's some context in there, and there's also just some regular questions as well on solving for length of a side.